So question 8 and question 9 bring in positive skew and negative skew. Question 9 here, positive skew has more lower values than higher values, and negative skew in question 8 will be the other way around, starting off small and ending up higher. So this is my negative and this is my positive. So question 8, it's a worded question and it's about the mean and the standard deviation of sampling distributions, and we know from the central limit theorem that the sample mean, when they're asking in part 1 here, will be normally distributed. So even if we take loads of samples from this guy over here, they will be normally distributed, which is an amazing thing about statistics. The mean and standard deviation of the sampling distribution of the sample mean in terms of the underlying population, what they're looking for here is that the mu, the mean of the sampling population, is equal to the mu of the population. And we've seen in some of these questions that standard deviation of the sampling x bar is equal to standard deviation of the population divided by the square root of n, where n is my sample and my standard deviation of the population. So just expand out on those. In question 9 we're told that it's positively skewed with a mean of 150 and a standard deviation 65. To check the accuracy of records, officials plan to conduct a survey of 100. We've got our n, randomly selected homes. Sketch the sampling distribution of the mean home value of a random sample of 100 homes, and clearly indicate on your diagram the location of the mean of this sampling distribution and the location of the points, 3 standard errors above and below this mean. So let's have a go at sketching the sampling distribution of the mean. Now, if you watch these videos, you'll see that I try to do them all the same. It's a normal distribution. That's all you're going to be sketching in leaving cert statistics. Here's my average, which we're told in the question is 150,000, and we're looking for, I'm just going to rub out the lines, the location of the mean and the location of the points, 3 standard errors. So I'm going to just mark in 3 standard errors down here, minus 3 sigma. I can put sigma over root n, I can just put sigma of the sampling that we're doing, and plus 3 standard deviations plus 3 sigma x bar of our sampling distribution, and we need values for those. One standard deviation is 65, so 65 times 3, 180 and 15, 195. So add 200 on, 350, so 345,000 on this end. Cardinal error is to forget about your n. So I've got my 65,000 over my square root of 100, not 1,000, square root of 100. So that is 6,500 by 3, 19,500. So we're up to 169,000. So 169,500, I'm taking away 19,500, you're going to get 130,500 down here. So that's our question 9.